Good afternoon, dear students. Yes. So, in the previous class, we were discussing the reactions. Okay, the reactions of haloarenes. So, these were the reactions. Okay. So let me revise. Okay, so these were the chemical properties. Okay, that is the chemical reactions of aryl halides. Okay, so first we have seen what is nucleophilic substitution reaction. Then we came across what is electrophilic substitution reaction, and then reaction with the active metals. So why nucleophilic, aryl halides are less reactive? Okay, why they are less reactive towards nucleophilic substitution reaction? Okay, so we have seen what are the reasons. Okay, first was due to the resonance. Okay, due to the resonance, when we write the resonance structures, we can see that the carbon halogen bond, okay, it is having a partial double bond character, thus it is very difficult to break the bond. Okay, so because of that, the aryl halides are less reactive. Then second was stabilization of the molecule by delocalization of electrons. Okay, and the third was instability of phenyl carbocation. And then one more we saw was benzene ring. Okay, as it is a nucleophile in nature, and so we cannot attack any other nucleophile on the benzene ring. Okay, because okay, because both the nucleophiles, okay, as both are negatively charged, so they cannot get attacked. Okay, so unless and until one is a positively charged, one is negatively charged. As you all know that unlike charges, they attract each other, and like charges, they repel each other, right? So same way, it is applicable over here also. So because so these were the reasons why aryl halides are less reactive. Okay, why they are less reactive towards a nucleophilic substitution reaction. Okay. So based on that, we have seen, then we had seen what is the effect of electron withdrawing groups. Okay, how it increases the rate of reaction. So this also things we have discussed. Then we have seen the electrophilic substitution reactions. Okay, as you all know, the halogens are ortho-para directing group. So it will give you ortho and para substituted product. Okay. So ortho and para substituted product. So based on that, we have seen what is halogenation, what is nitration, sulfonation, and Friedel-Crafts reaction. So these were the different reactions which we came across. So halogenation. So the halogen over here is Cl plus. Okay. So halogenation. So we have seen halogenation. So we know why it is a minor product and why it is a major product. So these things we have seen. Nitration we have seen. Nitronium ion is the electrophile. Then here sulfonation, sulfonic, okay, SO3H. Okay, so this is the electrophile. Then Friedel-Crafts alkylation and Friedel-Crafts acylation. So we take a alkyl halide. Here we are taking a methyl chloride in alkylation. Okay, and in acylation we are taking a that is a acyl chloride. Okay, acetyl chloride. So acetyl is your electrophile, and here is a methyl, okay, methyl cation. Fine. So these were the reactions. Then we have seen the reactions with metals. So as we were discussing it at the last moment, so let me summarize it once more. Okay. So, yeah. So Wood's reaction. Okay. So okay, so as we are discussing in Wood's reaction, what is happening in Wood's reaction, students? In Wood's reaction, we have what? In Wood's reaction, we have alkyl halides, right? We have what? We have alkyl halide. So two molecules of alkyl halide reacts with a sodium metal. Okay, in the presence of what? Dry ether. In presence of dry ether, what it gives you? It gives you a higher alkane. Okay, it gives you a higher alkane. So this is your what? Woods reaction. Then we have seen what? Fatigue reaction. Let us see about fatigue reaction. Okay, what is fatigue reaction? In that, we are going to take two aryl halides. Okay, so we are going to take two aryl halides. Okay, we are going to react with two molecules of aryl halides with sodium, active metal like sodium in the presence of dry ether again. What will the product obtain? The product obtained will be a alkyl aryl. Okay, so arenes. So it is a diphenyl ether. Okay, it is a diphenyl. So it is a diphenyl. Okay, and plus 2 NaX. This is fatigue reaction. So fatigue reaction is applicable for what? Arenes. Okay, both the molecules are arenes, and here it is for alkyl groups. Okay, for alkyl groups. Then next is Wood's fatigue reaction. Next is Wood and fatigue reaction. Wood's fatigue reaction. Okay, let me tell you about Wood's fatigue reaction. So in Wood's fatigue reaction, what in Wood's we are taking one alkyl halide, and in fatigue we are taking, okay, one aryl halide. So one alkyl halide, one aryl halide, we are going to react it with active metal like sodium. Okay, in the presence of dry ether, what we are going to get? Yes, we are going to get a alkyl arene. What we are going to get? We are going to get a alkyl arene as the product. So this is the main important reactions. Okay, Wood's reaction, fatigue reaction, and Wood's fatigue reaction. Is it clear? Yes. So these are the very important reaction asked for 2 marks. Okay, important question asked for 2 marks. Okay, so each okay. So how you have to study? Explain Wood's reaction with an example and study its general reaction also. Explain Wood's fatigue reaction with an example. Explain fatigue reaction with an example. Okay. So next we are going to see the dihalogen derivatives. Okay, we are going to study the polyhalogen derivatives. So polyhalogen derivatives of your haloalkanes. Okay. So yes. So just a second. So in so these are the applicative part. Okay, we are going to see the application part. So what are the dihalogen derivatives? Okay, so when two of the, now suppose I have a methane group. So in methane, when two of the hydrogens are replaced by what? Cl2, okay, or halogen atoms, then they result into dihalogen compounds. Okay, so when you have a dihalogen derivative, so we are going to see some examples of dihalogen derivatives. So first one is a dichloromethane. Okay, dichloromethane is what? It is example of a dihalogen, di, okay, dihalogen derivative. So this dichloromethane, it is widely used as a solvent. It is used as what? It is used as a solvent. It is used as a propellant in aerosols. Okay. Then a direct contact of dichloromethane in humans cause intense burning and milk redness of the skin. So if the human being, okay, if the human being, if it comes in contact with the dichloromethane directly, then the skin of the human being it will start to get burned. Okay, so there will be redness seen in the there will be redness seen in the this your reaction. You can see here. So what is the reaction? So vicinal dihalides. Now what do you mean by vicinal dihalides? You know now what is vicinal dihalides, right? So vicinal dihalides are what? So the halides, okay. So the halogen atoms, when they are present on the adjacent carbon atoms, okay. When they are present on the adjacent carbon atom, then they are called as what? Vicinal dihalides, right? So you can see. So these are the two halogen atoms which are present on what? Two halogen atoms present on two different carbon which are close to each other, which are side to each other. So they are called as what? Vicinal dihalides. So vicinal dihalides, okay. And here, this is a geminal. What do you mean by geminal dihalide, students? Geminal means what? Geminal means they are present the halogen atoms are present on the same carbon atom. Okay, they are present on the same carbon atom. Then they are termed as what? Geminal. Then, then the one more class of halides, they are called as isolated dihalides. Okay, the Cl, both the Cl atoms you can see they are far apart from each other. Okay, they are far apart from each other, and they are isolated from each other. So they are called as termed as isolated dihalides. So these are some of the examples of dihalogen derivatives. Okay, so two of the hydrogen atoms are replaced by what? Halogens. Okay, so this is the first example. Next, we are going to see is trihalogen derivatives. Okay, trihalogen derivatives. So the example given is trichloromethane. Okay, trichloromethane, or it is also called as chloroform. Okay, it is also termed as chloroform. So how you, what is the method of preparation of chloroform? So uh, methane, okay, methane, you have to react it with, you have to do free radical halogenation. Okay, you're going to do free radical use of Cl2. Okay, in the presence of sunlight, and you have to do a controlled chlorination. Why control? Because we want to replace only three hydrogen atoms by the Cl. Okay, so if you so we are supplying only three molecules of Cl2. Okay, we are doing a controlled chlorination because we are replacing only three hydrogens. Okay. So from this methane, so we are supplying the light, we are doing free radical halogenation. What we obtained is the chloroform plus 3HCl. Okay, then one more reaction, haloform reaction. So by doing haloform reaction also, you can obtain the what? Chloroform. So haloform reaction, it proceeds by a three-step. The first step is what? Oxidation step. Second step is a chlorination step. And third step is hydrolysis. Okay. So first is ethanol. You do a chlorination on with that. You get acetaldehyde plus 2HCl. Okay, in second step, again, whatever the aldehyde you have got, acetaldehyde, with that you are going to do chlorination. Okay, and then you get a substituted product. So what you are doing here, your hydrogen, okay, hydrogens are replaced by Cl3. You can see here. Okay, plus 3HCl. So you are doing what? Chlorination. So what is happening here? We are doing chlorination in the second step. Then again, in the third step, whatever the chlorinated product we have obtained, we are treating it with what? Calcium hydroxide. We are treating it with calcium hydroxide. And what we are going to obtain? We are going to obtain the chloro. Okay, so these are the three steps. So this is the method of preparation of chloroform. So please remember the examples. So for example, for dihalogen derivatives, what? Dichloromethane, and this is what? Trihalogen, it is trichloromethane. Then what are the properties of chloroform? Okay, what are the different properties of chloroform? So oxidation of chloroform. So if you do oxidation on this chloroform, that is CHCl3, when it is treated with oxygen in the presence of light, okay, you get a COCl2, which is called as phosgene. And this phosgene, it is a poisonous gas. Okay, so when you do oxidation on chloroform, you get a poisonous gas, and this poisonous gas is named as phosgene. So important, please mark this as important. Question is asked. So which is the poisonous gas obtained on oxidation of chloroform? So what is the gas name? It is a phosgene gas. Okay, Phosgene, phosgene gas. Okay. Okay, so phosgene gas. So oxidation of chloroform gives you what? Phosphorus, that is poisonous gas, which is a phosgene. Okay. Now, to avoid this oxidation, CHCl3 in dark is kept in dark brown bottles and filled to the brim. Okay, 1% ethanol is added to chloroform, which converts harmful phosgene gas into diethyl carbonate. So how to avoid this? How to avoid this oxidation of chloroform? So we can avoid the oxidation of chloroform by keeping the chloroform bottles in the dark bottles, dark color, brown color bottles. So in that brown color bottles, what is kept? The this is kept. Okay, your what the chloroform is kept so that uh, it does not convert into the harmful oxygen gas. Okay. Now the third is that chloroform is widely used in the production of freon refrigerant R22. So chloroform is also widely used in production of a freon. Okay, so freon, which is used as a refrigerant, that is R22. Okay, so these are some of the properties of chloroform. Then on nitration, it gives tear producing insecticide substance chloroquine. Okay. So on nitration, so if you do nitration on chloroform, we'll get a insecticide. Okay, tear producing insecticide, which is the substance called as chloropicrine. So you get chloropicrine when you do nitration on chloroform. On dehalogenation, it will give you acetylene. So these are some of the important properties which you can see here. So on doing the dehalogenation, okay, on doing dehalogenation, it will give you what? Acetylene. You can see here acetylene. Acetylene means what? Carbon hydrogen with a triple bond. Okay, carbon hydrogen with a triple bond. So it is termed as acetylene. Then when you are subjecting it to hydrolysis, that is base hydrolysis in the presence of base, okay, you get a formate. You get a formate. Okay, so what is happening here? Your Cl3 are replaced by OH. Further on, further hydrolysis with water. Okay, so further hydrolysis with water will give you a formate molecule. Okay, so these are some of the important properties of what your chloroform. Next, we are going to see some of the important polyhalogen derivatives. So the first is tetrachloromethane. What is tetrachloromethane? The name is carbon tetrachloride. Okay, it is carbon tetrachloride. So that is CCl4. We are replacing, okay, if we are replacing all the hydrogen atoms by what? Chlorine. So, so this is the first what first polyhalogen derivative. Poly means more than three. Okay, more than three. So the when it is more than three, we are termed it as polyhalogen derivatives. Okay. Then the second example of a polyhalogen derivative is freon. Okay, it is freon. Then the third one is DDT. Third one is DDT. Okay, and the fourth one is perchloroethane. Okay, perchloroethane. So for you, first three are important: tetrachloromethane, freons, and DDT. Okay. So first we'll start with tetrachloromethane. Okay, what is tetrachloromethane? So tetrachloromethane preparation. Okay, so as we have seen for that is a uh, chloroform. Okay, how we have done controlled chlorination. Okay, here what we are taking, the starting product is a methane. So what we are going to do, we are going to take methane and we are going to do chlorination. Okay, in the presence of sunlight. So what we are supplying here, we are supplying 4 molecules of chlorine in the presence of sunlight so that all the 4 hydrogen atoms are replaced by the chlorine atoms. Okay, you can see it. So this is the reaction. Okay, so this is the first reaction from where we can prepare our carbon chloromethane. Okay, carbon tetrachloride. Then CCl4, so colorless gas. Okay, carbon tetrachloride, it is a colorless gas and okay, it is a colorless gas. It is non-inflammable. Okay, it is a non-inflammable. Then it is a poisonous liquid. This is a poisonous liquid and it is soluble in alcohol and ether. It is soluble in alcohol and ether. So these were the some of the properties. Then what are the uses? Okay, so carbon tetrachloride, it is used as a solvent for oils, fats, resins. Okay, then carbon tetrachloride is used in dry cleaning. Okay, and also it is used as a fire extinguisher. Okay, to okay, in, sometimes due to some leakage of gas or something, so there can be fire. Okay, so that time we call fire extinguishers. So this fire extinguisher, so it is named under pyrene. Okay, so carbon tetrachloride is also used as a fire extinguisher and it is under the name of HV means light. H nu. Okay, H nu. Yes, here you can see H nu. It is nothing but light. Okay, UV light. H nu. You know that energy is supplied in a form of H nu, right? That is Planck's constant. That is your instant. This right according to Einstein, energy is given by H nu. What is H is Planck's constant, and nu is the frequency. Okay, so H nu it is nothing but what? H nu is light. Okay, that is in the presence of U, right, UV light. So that H nu. Okay, so then it is used as a fire extinguisher under the name of firing. Okay, so now your what is important? Nothing. Okay, so your nothing much is important. Okay. Next is freons, very important. Mark this as important. Freons is important. So the question can be asked from freons. What are freons? Okay. The chlorofluorocarbons of compounds of methane and ethanes are collectively called as freons. So mark this as important. Please make a note of that. So the chlorofluorocarbon compounds. So that is CFCs. The chlorofluorocarbon compounds of methane and ethane. They are collectively called as what? Freons. They are collectively called as freons. Okay. And these are usually produced for aerosol propellants. Okay. They are used in aerosol propellants and refrigeration and air conditioning purposes. So freons are specially used in refrigeration. Okay. For refrigeration, for air conditioning purposes. So there we are making use of this freons. Carbon tetrachloride when reacts with antimony, okay, then antimony trifluoride in the presence of SbCl5 as catalyst, dichlorofluoroethane freon is obtained. Okay, dichlorofluoromethane is obtained. So not so important. So this is very important. The chlorofluorocarbon compounds of methane and ethane are collectively called as what? Freons. Okay. So example of one freon, please make a note of this. So that is freon 12. That is dichlorofluoromethane. Okay, so this is a dichlorofluoromethane. So this is the example. So how it is prepared? It is given here. Okay, so carbon tetrachloride, CCl4, when you react it with antimony, okay, antimony trifluoride, okay, in the presence of SbCl5 as a catalyst, you get what? You get your dichloro CCl2F2. Okay, dichlorofluoromethane. Okay. So this is a mark this as important. Okay. Next, going for the next. This is DDT. One more important. Okay, here also it is important. So mark this as important. So DDT. Okay. So DDT is the first chlorinated organic insecticide. So DDT, what is the name? PP dash dichloro diphenyl trichloroethane. Okay, very important. So mark this as important. So the name also, what is the full form of DDT? You have to write PP dash dichloro diphenyl trichloroethane. So what is DDT? It is a first chlorinated organic insecticide. And who discovered that? It was discovered by Paul Muller. Okay, Paul Muller. So these are the important points. How it is prepared? Okay, how it is prepared? It is prepared from chloral and chlorobenzene in the presence of concentrated H2SO4. So the structure is important. Mark important for 1 mark. Okay, mark it important for 1 mark. The structure is very important. So C, okay, carbon, ClCl, CH, okay, then here and here. So this is 2,2, okay, what is the name? 2,2 bis, okay, 2,2 bis, 4 chlorophenyl, 4 chlorophenyl, 1,1,1 trichloroethane. So we are abbreviating like this, okay. So this is the important. So please mark the structure as important. DDT structure is very important. So what is DDT? So DDT, it is a first chlorinated organic pesticide. Okay. So, so this is important. So the full form and what is DDT and the structure. I hope you are writing down the important points. Okay. So so this is important. Then freons you have marked important. Then carbon tetrachloride here, not carbon tetrachloride, a chloroform. Okay, in chloroform, I hope you have marked this as important. Wait, okay, so the freon. Okay, so this is important. Chloroform. Okay, where it is used in the production. So chloroform is widely used in the production of freon refrigerant R22. So important, mark this as important for 1 mark. So where a chloroform is widely used in what production? Okay, it is used in the production of what? It is used in the production of freon. Okay, it is used in the production of freon. Okay. I hope you have marked it. Then one more chloroform. Yes, this one. Okay, 1 mark, important. Oxidation of chloroform. Okay, upon oxidation of chloroform or oxidation when chloroform is slowly oxidized. Okay, in the presence of air or light. Okay, it gives you extremely poisonous gas, which is called as what? Carbonyl chloride, or it is also termed as phosgene. So with the reaction, important. With the reaction, mark this also important for 1 mark. Okay, so the reaction is important. CHCl3 plus O2 in the presence of light gives you 2COCl2 plus 2HCl. Okay, is it clear? So these are the important questions. Okay, from application of polyhalogen compounds, you will get the question from this. Okay, that is a chloroform. So these are the two important things. Then you have to come up across the this freons. Okay, what are freons? Okay, what are freons? And next is the structure of DDT. Okay, I hope this is clear. Yes. Okay. So this completes our chapter, haloalkenes and haloarenes. Okay. So any difficulty up to here? Any doubts?
Once again, teach me the nucleophilic reaction.
Which nucleophilic reaction? SN1, SN2 or haloarenes?
Haloarine.
This one?
Yes, ma'am.
Okay, fine. So we'll see the nucleophilic substitution reactions. Okay. So basically, the aryl halides, they will undergo these three. Okay. Nucleophilic substitution reaction, electrophilic substitution reaction, and reaction with metals. So as we are discussing about nucleophilic substitution reaction, it will be little difficult because benzene is what? Benzene is a nucleophile. Okay. Benzene is a nucleophile. Nucleophile means what? It will be electron rich. Okay. It will be electron rich. Now nucleophiles like OH minus, Cl minus. So these are also what? So these are also called as nucleophile. Now these are nucleophiles. So these are also electron rich. So electrons. Okay. So these are negatively charged. This is negatively charged. So like charges, they will repel each other. Okay. Now, so because of the presence of the, what is that? So it is very difficult to undergo a nucleophilic substitution reaction on a benzene substituted compound. Okay, because the electron rich nucleophile will experience a repulsion. Okay, when it approaches the electron rich arenes. So whenever it approaches the benzene, whenever any nucleophile will approach the benzene, what you will see? You will see a repulsion. Okay, you will see there will be repulsion. So this can be first point why aryl halides are less reactive towards nucleophilic substitution reaction. Okay, then a few more points. So a few more points. So this was the first point. Okay, due to the repulsion. Okay, so because the electron rich nucleophile. Okay, let me write the points. Electron rich nucleophile experiences a repulsion. repulsion when approaches to a electron rich arene. Okay, so this is the first point. Then second point, it is due to resonance effect. It is due to what? Resonance effect. Resonance effect, that is a plus R effect. Now what you can see in resonance effect? Now this is a haloarene. Okay, so this is a haloarene. So haloarene. So okay. So this is a haloarene. We have taken a chlorobenzene. Okay. Now this chlorobenzene, what is happening here? Here. Okay, so this is a chlorobenzene. Now, what is happening in resonance? So when you see the resonance structures, okay, now this is a lone pair of electrons of chlorine that will involved in the bond formation. Okay, it will undergo the resonance structures, and what will happen here? So it will undergo the partial bond formation. Now here, so the charge is moving, so the charge has moved here, so it will reach here. So this you will get positive charge, Cl. Okay, then this will be having a positive charge. Now this Cl, what is happening now? This negative charge will be what? It will be stabilized. It will be resonance stabilized. So now the same. So here the positive charge is there on the chlorine. Okay. Now the negative charge is here. Okay. So this will be resonance stabilized. Okay. Then again we get the structure. So negative charge will be here. So Cl. So again the negative charge will move. Okay. And you will get back your chlorobenzene. You will get your what? You will get back your chlorobenzene. Okay. So now when you write the, when I'm writing the resonance structures, okay, you can see that your CCl bond here is your CCl bond, right? This is your CCl bond. So what is happening? That when you're writing the resonance structures, you see that the CCl bond is having what? It is having a partial double bond character. Okay, it is having this double bond character is not fixed, right? It is a partial. Partial means what? This will be because because we are stabilizing the negative charge. Okay, so the bond is moving, this bonds are not intact. Okay, so these bonds are not intact, they are not at that fixed, so the pi bonds, they are moving. So what is happening here? The CCl bond is getting a partial double bond character. It is having that partial double bond character. So as a result, what is happening? The bond cleavage, okay, to break this bond between the carbon and chlorine, to break the bond between the carbon and chlorine in this haloarenes, it is very difficult. It is very difficult because it is a double bond. So when you have a single stick, okay, to break the single stick, if you put a little force, you can break it easily. But if you have double stick, if you have two sticks in your hand, and if you try to break the sticks, is it possible? No, right? It will be a slightly difficult task. Okay, so as a result, when this resonance structures, when we write the resonance structures, we can see that the CCl bond is getting a partial double bond character. So because of that, as a result, you can see that the breaking of the CCl bond is, it will be a bit difficult. So because of these are less reactive towards the nucleophilic substitution reaction. Because see, now what is nucleophilic substitution reaction? Yes, so CCl. Now this is what is that? This is your haloarine. Okay, now I want to substitute with another nucleophile. So to break this CCl bond is getting difficult. So how I can do a nucleophilic substitution? I should break this bond and I should introduce this nucleophile on that. So it is undergoing a very difficult task, okay, to break this CCl bond in the haloarine. So because of that, it is less reactive towards nucleophilic substitution reaction. So this is the second point. Now third point is what? Third point is difference in hybridization. Okay, difference in hybridization. So let's see, the next one is difference in hybridization. Now what is the difference in hybridization? Okay, now when we see the difference, okay, of hybridization of carbon in CX bond. Okay, so what will be the difference? So when we see the what is this? This is a haloarine. So when we see a haloarine, okay, when we see a haloarine and when we see a alkyl, you can say a haloalkane. Okay, this is a haloalkane. Okay, so what you can see here, what you can see here, yes. So here R C. Let me take another color slightly. R H. Okay. So when we are taking, so we this is a haloarine and this is a what? This is a haloarine, and this is your haloalkane. Okay. Now here when you can see what is the hybridization over here of this carbon, at this carbon it is sp2 because it is having a double bond, right? It is having a double bond. So this is sp2. Now what is the hybridization of this carbon? It is sp3 because it is joined to a single bond. So the sp2 hybridized carbon, okay, the sp2 hybridized carbon will have a greater s character. Okay, it is having greater s character and it is more electronegative. Because of greater S character, it is more electronegative. And what does it will hold electron pair? So it can hold more electron pair. Okay, and thus the CX bond is more tightly holded here. The CX bond is it is holded more tightly as compared to that of the sp3. Okay, or sp3 hybridized carbon of this haloalkane. Okay, because it is very difficult to break the bond in case of your sp2 hybridized carbon as that of the sp3 hybridized carbon, because the electrons are tightly holded over into the sp2 hybridized carbon. So this is another reason why haloarenes are less reactive towards the nucleophilic substitution reaction. Okay. Then next point is instability of phenyl carbocation. So you have to explain this. Okay. The next is instability of phenyl carbocation. So in haloarenes, the phenyl carbocation formed as a result of self-ionization will not be satisfied by resonance, and therefore SN1 mechanism is ruled out. Okay. So when we are writing the phenyl carbocation, I have that, just a second. Huh? Hmm. Okay. So when we have the instability in phenyl carbocation, when we are discussing about the instability of phenyl carbocation, okay. So here, so whatever. So in the haloarenes, the phenyl carbocation. So the phenyl carbocation means what? When you have a benzene, so when you break this bond, okay, if you break this bond and you have a positive charge on this phenyl, so this phenyl carbocation, okay, which is formed as a result of self ionization, when this CX bond is broken, it won't be satisfied by resonance, because in SN1 mechanism, okay, in SN1 mechanism is ruled out. We cannot do SN1 mechanism on the haloarenes. Okay, so this is another reason why aryl halides are less reactive. So these are the four important points. Okay, so these are the four important points. So first is you can write about the resonance, due to the resonance. Okay, and you have to explain these all things. Then second is difference in hybridization, okay, of carbon atoms in the CX bond as when you compare with haloarenes and haloalkanes. Then the third is instability of phenyl carbocation, and the fourth is that is electron-rich nucleophile will experience repulsion when it is approached with the electron-rich arenes, because both the your benzene as well as your nucleophile. So these are electron rich. So there will be repulsion cost, okay, when they will approach each other. So these are some of the reasons why nucleophiles or aryl halides are less reactive towards nucleophilic substitution reaction. Okay, is it clear? Any other doubts? So this is very
No, ma'am.
important, as I've told you before. Okay, very important. Ask for 3 marks. So I have been telling you. So what are the important things? Okay, from exam point of view, I hope you have marked out the things. Okay, so all the name reactions. So when you are studying the name reactions, so please study the name reactions with the examples. Okay, practice the examples regularly. So it won't. You don't forget them easily. Okay, so just practice the examples whenever you are studying the mechanism. Okay, so with the SN1 SN2 mechanism is important. Then the all the name reactions are very important, and whatever the things. Okay, then this electrophilic substitution reactions, that is halogenation, nitration, Friedel graph, alkylation, Friedel graph, acylation, right? So these all things are important. So whatever have been told about the haloalkanes and haloarenes, okay, I hope you have understood everything, okay, and start studying, okay. So it will you won't get confused, because after this there are still more organic chapters, okay. Now you won't feel so much difficult, but when we start those also, so there also again you'll be having the reactions mechanism. So again, at the end of the day, you will get confused. So now and then itself, you start practicing them. Okay, it won't be a difficult task at last. Okay, okay. So any other doubts?
Excuse me, ma'am.
Yeah,
Ma'am, how much elements we want to remember the atomic number and the atomic mass?
atomic mass. For what you want to remember? For because in the at least 30, up to 30, you need to know. But for exam point of view, if what is that? Now some of the important compounds. Okay, suppose AU, then Br, iodine, chlorine, sulfur, sodium, potassium. So these are some of the compounds which are asked repeatedly. Mn, okay, chlorine, Fe. So like this, some of the atoms, so their atomic mass, atomic number are to be remembered only. Okay, and for if you are talking from point of view of exams, okay, for problems and all, they will give you atomic masses. Okay, they will give you atomic masses in the questions. Okay, but for your understanding, whatever the important these are there, what important elements are there, that you have to know. Okay, so first 30 is compulsory. After that, you have to know which are the important ones. So that you have to remember.
Okay, ma'am.
Okay. Any other difficulties others are having? So haloalkanes and haloarenes is understood. So we have completed 2 chapters, solutions and haloalkanes and haloarenes. Okay. So from tomorrow we are going to start. So we have completed 1 physical chapter and we have completed 1 organic chapter. So tomorrow I'm going to start with a new topic that is from inorganic chemistry. I'm going to start D and F block elements. So before coming for the class tomorrow, please study some few things about D and F block elements, okay, so that it will be more clearer for you. I hope everything is clear. Fine. So no more difficulties, no more doubts.
No, ma'am.
Okay. Others, only one girl is active. What about others? Fine. Okay. So no doubts. Okay. I hope you have studied solution chapters. Okay, I hope you might have you're studying solutions as well as the haloalkanes and haloarenes. So till now, I hope solution might have been completed from your side. So start now, start studying the haloalkanes and haloarenes. So we have completed 2 chapters. Okay, so tomorrow we are going to start with the third chapter. So I'll put the notes. So notes will be added in the Google Drive. So get downloaded and go through the notes. Fine. So whatever the important things I've told, please study them. Okay. So I'll end the session here. We'll meet in the next class. Thank you.